It is my absolute pleasure to introduce Aaron Warren, who's going to be talking to us about what sleep architecture looks like, right? So stage 1, stage 2, non-REM, REM, in patients who have the RNS implant, so deep brain stimulator. And I am so excited about this. Aaron is one of our LGS Foundation grantees, and he's just this really kind of mild-mannered, quiet gentleman, and I fangirl all over him and his science all the time, so he doesn't quite know what to do with me. But here he is. Aaron, thank you for being here and for presenting later. Come on up, and can't wait to hear. Thank you.
Thanks, Tracy. Thanks for the privilege to speak today. The format of this conference, mixing kind of clinicians and researchers and families, is really quite unique and challenges us to think outside the box. So I'm Aaron, and today I'm going to talk about some exciting preliminary results from a project being funded by the LGS Foundation, looking at sleep in LGS and how this might be a novel treatment target to reduce seizures. So I don't have to tell this audience that LGS is much more than just seizures. It affects many aspects of daily living. Research conducted by the LGS Foundation a few years ago found that nearly 90% of caregivers were reporting sleep disturbances. Oh God, my animations are killing me as usual. Here we go. So we know, as Dr. Shellhouse kind of talked about earlier, poor sleep is a kind of risk factor for a whole range of negative health consequences. It increases the risk of everything from mood disorders to diabetes and even cardiac issues. So to improve sleep, though, we can't ignore seizures because they're closely linked. We know that sleep and seizures have this kind of bidirectional relationship where one affects the other. Seizures in LGS are more common at night, following a kind of circadian cycle, and we know that nighttime seizures increase the risk of SUDEP. On the other hand, seizures can disrupt sleep, causing awakenings or interfering with important brain functions like sleep spindles, which are really crucial for learning and memory. So improving sleep quality might reduce seizures and SUDEP risk while preventing the other health issues linked to poor sleep. So brain stimulation devices like RNS offer promising opportunities to study this interaction and potentially reshape the sleep-wake cycle. As Dr. Morell explained earlier, the RNS device records brain activity segments both during seizures and during periods without seizures, and the data can be wirelessly uploaded for us to analyse. There we go. So the device can be programmed to record at specific times of day, making it a powerful tool to track circadian rhythms in brain activity, how they change over time, and their association with treatment effects or seizure changes. So what do we mean by tracking these rhythms? Here's an example of one segment of neural activity recorded from an implanted device. The recording has two main parts: a periodic or oscillatory component showing rhythmic fluctuations, and it's the kind of one in blue, and an aperiodic or non-oscillatory component that doesn't really have a clear rhythm, and that's the one shown in red. So this non-rhythmic activity is linked to important brain functions, including the balance between excitation and inhibition, which affects how likely brain cells are to fire. In the healthy brain, this balance is maintained, but in epilepsy, it's disrupted, especially before a seizure. So why does this matter for the sleep-seizure relationship? Some recent work from our lab, led by Chantal Charbois, found that the strength of a circadian changes in this activity correlated with RNS outcomes in people with focal epilepsy. So for instance, this person became seizure-free and showed really well-organised day-night fluctuations in their data. And in contrast, this person with a poor response to RNS had little to no circadian rhythm. And then when the outcomes were plotted for the group, there was a significant positive correlation, suggesting this might be a potential biomarker of treatment response. But what about in LGS? Does the same thing happen here as it does in focal epilepsy? To find out, we're collecting similar data as part of the RNS system LGS feasibility study that Dr. Morell outlined earlier today. So the trial will implant 20 people with LGS with 2 devices targeting both the cortex and the thalamus. And we plan to test 2 hypotheses. First, we hypothesize that baseline seizure severity before surgery will correlate with higher overall aperiodic activity in post-implantation recordings and weaker circadian changes in this activity. So in other words, we're testing if daily fluctuations in this activity, which might be an indicator of sleep quality, affect seizure likelihood. And then secondly, we predict that RNS efficacy will correlate with a kind of return of stronger daily rhythms in this activity. Before we get to that point, though, we first need to decide where to implant the device in a way that best targets the LGS brain network, since we can't really implant electrodes everywhere in the brain. To do this, we used previous imaging studies that identified the areas most active during epileptic activity in people with LGS. We combined these studies to find the area where there was the most overlap. And when we did this, there was a small area of the frontal lobe in a region called premotor cortex that showed peak involvement across the studies. So armed with this knowledge, we developed a strategy for bilateral RNS device implantation, positioning one lead over the frontal lobe spot and the other in the thalamus. So these images show the typical electrode positions from some CT scans. So far, we've got data from 13 people, and there's more to come as the trial goes on. In our initial analysis, we've looked at recordings from the first 3 months after surgery, when the device records activity, but it doesn't deliver any stimulation. So this lets us see each person's typical activity before treatment affects it. So in the first analysis, we just compared day and night recordings and saw higher overall aperiodic activity at night, consistent with sleep-related increases. However, the magnitude of this difference was very different across individuals. So for example, this one person, the activity was actually higher during the day than it was at night. So one reason for this could be that different sleep-wake patterns occur amongst people with LGS. So some of them sleep a lot during the day and are restless at night, and others, the reverse is true. So to address this, we clustered each person's recordings by their similarity, regardless of the time of day they occurred. And so this method helps us to define clusters of recordings where the person is most likely asleep, and those are the dots in blue, and times when they're most likely awake, the dots in orange. So in other ways, it allows us to look at the data in a way that accommodates each person's own sleep patterns. So we're still exploring the data, but preliminary analyses seem to support our hypotheses. So we found a positive correlation between overall aperiodic activity and seizure burden before surgery. And this was true when we looked at drop seizures only, the plot on the left, and when all seizures were combined, the plot on the right. So this suggests that aperiodic activity might act like a temperature gauge in the brain, tracking the susceptibility to seizures. This could have important implications, like providing a rapid, objective way for therapy adjustments instead of waiting for weeks or months from seizure diaries, which we know have a lot of problems. So conversely, when we looked at differences between recordings performed during sleep and those performed during wakefulness, we saw that patients who had a greater difference, or in other words, a stronger sleep-wake cycle, had a lower baseline seizure burden. And again, the results were similar when looking at drop seizures only or all seizures together. So we need to repeat this analysis and perform some formal statistical testing when we have the data from the full cohort, but we're excited by these early results. What they suggest, as caregivers have been telling us for yonks, is that when their loved ones have better sleep, they're less likely to have seizures. So the key takeaway is that sleep-wake cycles are really important. When disturbed, they can aggravate seizures and may even prevent treatments from working, as seen with the RNS data from people with focal epilepsy. Daily rhythms in aperiodic activity, which likely reflects the balance between excitation and inhibition in the brain, might help track seizure burden and its changes with therapy. In the future, this could be a treatment target itself. Instead of playing whack-a-mole with seizures, as current devices seem to do, we could aim to restore healthy sleep-wake cycles. This might involve adjusting stimulation to prevent daytime sleepiness and promote nighttime sleep. And besides other stimulation therapies, other techniques like behavioural interventions might also play an important role in promoting better sleep. So with that, I'd just like to acknowledge all the amazing people who are contributing to this work, particularly the families and patients who are participating in the trial, and of course to the LGS Foundation for partnering with us on this work. Thank you.
That's fantastic. Thank you, Dr. Warren. I have a question, and if there's any questions, please raise your hand. We have time for questions. So the generalized paroxysmal fast activity, GPFA, is often affiliated with tonic seizures, and those are often affiliated with sleep in our children and then in our adults. Do you see anything in the RNS data, right? Because you said, you kind of lumped it all together regardless of time of day, but do you see an increase in tonic seizures at night? And do you know what's happening within that LGS network? Because what Dr. Warren didn't tell you is he did all that work, original work on the LGS network, right? Him and his team in Australia. But do you have any sense of what's happening? Like, why night? Why tonic seizures? What's going on? Love to hear what you think.
Yeah, really good question. So for your first question, yes, the RNS kind of provides amounts of detections of seizure activity over time. And in the patients we've looked at so far, there definitely is an increase in the detections at night compared to day. But like I was saying earlier, the particular pattern that each person follows is unique to them. Why we see sort of tonic seizures at night and during sleep? Open question. One possibility is that the kind of seizure network that tonic seizures are expressed through overlaps with the same kind of networks that become active during sleep. So when you get two of them going together, maybe that's why you sort of see a co-occurrence. I think, the trial, the kind of data we're collecting from this is totally, the first we've ever sort of seen of this kind of data. So it's super exciting. The more we sort of understand what's actually happening in these recordings, we might be able to then go tie it back to what we know about the network. But
Yeah, thank you. That's fantastic. It is really exciting to think that, with the RNS system, you're simultaneously recording from cortex, and then they're stimulating deep brain stimulation in the thalamus, and then actually taking this data from the real world, from patients who are living with LGS is remarkable. And I was really excited when we read your project. Any questions about, right here. Do you have a mic yet, Carl? I'll get you one. I know we have some mic runners. Just raise your hand. Oh, here she comes. She's going to beat me. It's a race.
Hi, thank you for that. Question is, the chart showed drop seizures. Is that tonic seizures?
Yeah, I wish Dr. Morell was here. She knows the sort of exact definitions of the inclusion-exclusion criteria and how seizures are counted. My understanding is it was like all countable seizures that either could or did result in a fall or a drop. So I think that would largely be tonic seizures, but it would include like a whole range of other seizure types that could cause a fall.
Okay.
Yeah, so it's usually like tonic-clonic, mild-clonic, sometimes if they're severe, atonic.
Because if they're asleep in a bed, you can't measure whether they fell or not.
Exactly, yeah. That's one of the huge limitations of seizure diaries, and potentially why some of the work we're doing will provide like an alternative way to like, I guess, titrate therapy. So if you have like a biomarker of how likely the brain is to cause a seizure, in the future we might not even have to count seizures anymore. We'll just have this kind of like gauge we can test, I guess.
Are there caregivers inputting all seizure types that they see, and for now you're just not counting those, but may in the future?
So again, like the kind of ways that seizures are defined is beyond my knowledge in the trial, but my understanding is like they're sort of counting seizure types, specific seizure types, and then the outcomes are being defined both kind of in terms of the like percentage reduction in seizures, but also things like whether or not someone had that seizure on a given day and the number of days they have a given seizure. I don't know if that answers your question or not.
Yeah, so this is often how clinical trials are done as well, where they count, major motor seizures, major motor drop seizures, and they lump them all together. So the family's counting everything. Or the company who's doing the trial will really work with the families to just identify the atonic, the tonic-clonic, the myoclonic, the really fierce myoclonics, and the tonics that would throw them to ground. And it used to be that you had to assess, like, would it have thrown them to the ground if they, had been up, right? Because we can tell, we know, right? If it's a big one. But, the definitions kind of change for each trial. And what's really interesting about this is they're also recording at the same time, right? So they can back up whatever the patients are reporting along with what they're seeing on the EEG. And what I guess I don't know is if the patients in this trial are counting everything or if they've just been told to count these few types of seizures.
Yeah, I think they're sort of not instructed to count like absent seizures, for example, because they're very difficult to measure reliably. But yeah, like as Tracy was saying, the kind of cool thing about RNS trials is you have this more objective like marker of detections. We don't actually know if like a given detection correlates with a seizure. All we're sort of saying is like, oh, there's a detection of abnormal seizure-like activity, but whether that manifested clinically, we can't say. But if we see a correlation between like diary-based seizures and what the device is telling us, I think that's like a fairly strong sort of way of defining outcome.
Thank you.
And the trial that Marty was doing in focal seizures, they did see that that there were a lot of seizures that were missed by the counters, but the counters were often not caregivers. They were often people with epilepsy. So this is sort of a different type of trial where they're looking at caregiver-reported seizures in RNS patients. So I think we have another question back there. Kara, yeah. Lori.
Yeah, hi. So I've been under the impression that RNS is appropriate when there are focal seizures. Now it sounds like that's different. Is RNS
Aaron.
now?
Aaron's like, I'm a PhD over. I am too, Aaron. I've just been doing this a while. So it's approved for focal seizures in epilepsy. It is not approved for generalized seizures. There is a clinical trial right now being funded by the government to look at RNS specifically in LGS patients to see if there's an effect. And Dr. Warren here is working closely with Dr. Morell's group, Marty Morell, who spoke earlier about the RNS trial, where he's actually taking the patient's sleep data, and looking into it. And so while it's not approved for generalized seizures or for seizures associated with LGS, there's a study going on. And then I will just tell you that it is being used off-label. And a lot of people in our online private caregiver community are talking about how their loved one has been implanted with RNS or with DBS. And Dr. Joshi talked about that. Sharita Joshi, who was on, was talking as well about it. But if you look at FDA approval, you're right. It is not FDA approved for anything but focal seizures.
And that study is already closed?
That study is, it's still ongoing, but they have all their enrollees, right? Is that the last you heard. Yeah,
Yeah, I think
that's the last I heard from Marty as well.
Okay, thank you.
Okay, I think that's it. Aaron, really exciting work. Thank you. And next time we'll put you and Marty right back to back so that you can do the clinical and the basic science together. But thank you. Hey, Aaron, stick around. There might be another question for you. Go ahead and read it, Hannah. We have an online question, yeah.
Okay, there we go. So Jane asks, are nocturnal tonic-clonics typically at different stages or duration? I'm looking for patterns discovered.
Oh, right. So I'm not too sure about tonic-clonic seizures specifically, but we do know that tonic seizures are more common during non-REM sleep. So that's the kind of like lighter stage of sleep, not so much the deeper stage, which is like REM sleep. And in particular, what we think is that the transition points between non-REM sleep and REM sleep are when seizures are most likely to occur, when you see these like massive state changes in the brain. But we haven't sort of looked at, like how that differs by different seizure types or anything like that.